Here is my strong recommendation for the assignment. This is, I started following this strategy like second year, and it worked really well for me, and this is what I did. As soon as the assignment was released, I'd read it with no expectation of writing a single line of code for a while. I just wanted to read it because reading it and understanding what it's asking you to do is step number one. Remember, computer science is not programming. That's like saying someone who's an English major, their thing is all about using a pencil and paper. Like, that's ridiculous. It's about the identification of what it's actually asking you to do. Like, what is the problem that needs to be solved? It's coming up with the strategy for solving the problem and then coding the problem and making sure it's right. Obviously, at this stage, when you're just learning to program, the programming part is non-trivial, right? Like, it'll take a little bit to maybe pick up. But once you start to get in the zone, you know, you're comfortable enough programming, maybe by the second, possibly third assignment, the hard part is, like, well, what is the algorithm I need to do? Because the algorithm is like the set of steps in the order that you do them. The code is just you writing your algorithm for Python. So I would always read the assignment and just let it brew in my head. You know, maybe I'm watching baseball, but just kind of like just thinking about it in the back of my mind. I swear to God, this isn't a joke. Most of the degrees that I have, I did all of my thinking in the shower in the morning. It's where I like figured everything out. The number of times I've just been standing in the shower and going like, that's how I solve that problem, is hilariously large. I have publications. I have scientific articles published about things that I thought about in the shower. I mean, I don't write that in the article, of course. Maybe I should, and then everyone else could admit, you know. But I mean, there is the science to support that, like, meditative mentality for finding solutions to problems. Some people go for walks, and they always think of their solutions all like a long walk. Me, I'm the shower type of person. I solve all the world's problems in the shower, if only they were useful solutions. Yeah, so that's my strategy. So I suggest, if you haven't yet, read the assignment, get a sense of what it is you have to do, and just let it brew. Sometimes it'll just passively come up in your head. I would love to see a programmer go, okay, let me read the assignment. Okay, I'm working on it now. I'm thinking. Like, no, that's not how thinking works, right? Like, you don't just sit there and go, for hours. Like, no, you just kind of like think about it while you're doing other things. And then next thing you know, you've kind of come up with a rough solution. You start coding. Maybe some of the solution you came up with is good. In other parts you go, oh, I see the problem with that. Okay, well, how do I? That's what you do. If you raise your hand if, like, yeah, this is the first computer science you've ever done. All right. There are some courses where, yeah, if you start working on the assignment in the afternoon on the day it's due, you could get it done. Computer science is not one of those courses. You've been warned. Computer science, I'm not saying it's hard, but it's not easy. It definitely isn't easy. If it was easy, everyone would do it and get paid the big bucks that programmers get paid. Because they get paid big bucks. But that's because it's kind of tough. Not everyone can do it. I have faith in all of you. You all can do it, of course. But you gotta practice. So, I don't know, if you start to think like, oh yeah, I can whip up a solution to this in an afternoon, I don't think that's smart. Maybe you can, great. But that probably won't last very long as the problems that you need to solve get a little bit harder and harder and harder. Because this first assignment is, in the context of first year computer science, is going to be the easiest one. That doesn't mean it's easy. That just means relative. It's probably simpler. But it's not trivial. So make sure you give yourself enough time. Oh right, I wanted to check to make sure the mic was oh good, the mic is working. Yeah. So, and yeah, any questions about that? I mean, that's the strategy that worked for me. maybe you have another strategy that works for you, great. But if you're looking for a strategy, I don't know, that worked for me, maybe give it a go. And it's gonna be, that strategy is gonna become that much more useful as the problems get more and more challenging, complex. Yeah, any questions about that? All right, so let's carry on. Last time, it was all about Booleans, right? But we have, like, I talked about operators, Boolean operators, but some of them, like, they're kind of different, right? Addition, the plus sign. It's an operator that takes two numbers and gives you back a number. We also saw, like, and or. Those are operators that take two Booleans, true or false. I mean, when I was doing the example of, like, am I wearing a hat and shoes, you might say, but there was no true false there. Yeah, but the statements about, like, wearing a hat, wearing shoes, those can be evaluated to true or false. So just remember. A lot of people, if I say true and true, they kind of lose sight of what that really means because they're so used to seeing, like, a question instead of just a Boolean value. I'll show you an example of that in a second. Anyways, and or, an operator takes two Booleans and gives you back a Boolean. But I also quickly showed you at the end of class to check if two numbers were equal. I also showed you to check if a number is greater than another number, or less than or equal to. Those are operators that, I mean, in this case, took two numbers, but it didn't give you back a number, it gave you back a Boolean. I'll show you. So let's say I do print, is 5 less than 6? True or false? True. Yep, connecting. Python's got to think about this one. All right, good. True, of course. What about this question? Everybody yell false. Of course it's false. So, what a ridiculous statement. Is 5 greater than or equal to 6? Well, let's check it. All right, cool. And then I tried to trick you last time with this. Is this statement true or false? On the count of 3, everyone's going to yell at the answer. 1, 2, 3. False. Good. Why? Because 5 is not greater than 5. That is a false statement. Well, no, that is a true statement. Saying 5 is greater than 5 is not correct. If I do 5 is greater than or equal to 5, well, of course. Of course that's true, because it is equal to 5. And you can ask specifically if two things are equal. This is a statement that gets evaluated. This is more like the equals that you're used to seeing in math. 2 equals. Equals equals is the question, are these values the same? So is 5 equal to 5? Yeah. No. If you say yeah, you're so wrong. It's true. So of course that's true. Is 5 equal to 55? False. Of course it's false. So, see, a number, but the result is either true or false. And for fun, let's do like, okay, 5 equals 55. And then here we'll print out res, which we know is going to be false, but we're also going to print out the type of res. So here, I'm asking the question, and you're like, whoa, there's 2 equals in that line? Well, they're different. Here is the statement. Here's the expression that can be evaluated. Does 5 equal 55? Where do I put the false? I store it in the variable res. Booleans are values, just like strings, just like none, just like integers, just like floating point numbers. They're values, and I can store those values in variables. So here, I'll store false in res, and then print out res in the type of res. And we see false, and it's a Boolean. Boolean. Kind of how like stir is for string. So it's a Boolean. And I mean, I can say that. I can write the literal true, but it's kind of boring, right? So going back, let's have fun. So print true and false is false, right? We saw this last time. True only gives you true if both values are true. Or only gives you false if both values are false. And we did briefly talk about the difference between or and exclusive or, because sometimes people think like, well, is or one or the other? But the or we're talking about is one, both, or the other one and not this one. It doesn't matter if they both are. Exclusive or, you can only have one. Exclusive or is not going to be, like, we're not really going to talk about it in this course. So we've got true and false. Now, this statement's kind of boring because it's kind of like saying, well, like I'm taking a literal, and I'm ending it, and so every single time I run this code, it's always going to give me back false, which is the way it is. But let's change this now, because and is an operator, and all and cares about is it gets a Boolean and a Boolean. So I can say, is 5 equal to, no, is 5 greater than or equal to 5 and 6 less than 77? Take a second and yell at the answer. True. Well, is 5, let's think about the evaluation here. We see and needs 2 Booleans. But we also have those 2 other little expressions in there that can be evaluated. Is 5 greater than or equal to 5? Like, come on. That was only a little bit better. Is 6 less than 77? So is 5 less than or equal to 5 and 6 less than 77 all together, true or false? True. Well, let's run it. Remember, this false is from the previous run. True. You know, we can start to go crazy. You know, we can start to have some real fun. Or not. Come on. 5 is equal to hello. Apparently that's true. All of that is true. So what was I asking? I was asking, is 5 greater than or equal to 5 and 6 less than 77, or is 5 not equal to hello? You think it's 7? Well, let's check it. Let's check it. I don't know, let's see what happens. Oh, it's still true though. But I guess it's because, you know, there's all that complexity, right? So maybe we can go like this. Is this going to be true or false? False. False? It's true. It was the or not that probably got you, right? Because all that matters, look, in fact, in this scenario, we could cheat a little bit. Because, look. And 88 minus 56. Oh. Is not equal. Here's another way to write like not equal. Is like exclamation point equal. Is not equal to this number, and 55 is equal to 56. And not 66 minus 43, 1, 2, 3. Right. So I mean, and let me zoom out a little. So here's a big, long expression, and the answer's true. And here, I can cheat a little bit. Because I can look at this whole expression and say, okay, I've got all these ands, it's one big, long, complicated question. Oh, but there's an or. So I can check what the right-hand side is. And if the right-hand side of that or comes out to true, remember, true or whatever is always true. Because it's either true or false, but that's true, or true, and that's also true. So it actually doesn't even matter at the end when it gets evaluated in this scenario. And because 7 equals 77 not is true, we're good. Anyways, any questions about that? I mean, they're just Booleans, they're just values. Yes?
Python with an exclamation marker, what does that mean in Python?
It means if I do like 5, here, let me take a step back and do this. So equals asks the question, are these values the same? The exclamation point, if I replace like the first equals with an exclamation point, what it's asking is, are these values not the same? That's all. So, well, false, because they are the same. Yeah. Good question, though. It'll sneak up on you. On some other programming languages, like here, we could also write not. Like, this would be equivalent to this. Right? Is 5 equal to 5 not? Which is just, it just doesn't sound as nice to say. But it's like the same thing. In some programming languages, though, if you want not, it's actually just like the exclamation point means not. Okay. I saw your hand up.
Now let's say if we didn't have any brackets and we just had like a condition and condition or condition, is there any order of operations that Python will follow?
There is an order of operations that Python follows. My advice is, when in doubt, use the parentheses just to make things very clear about the order you want it in. But if you want, you can go look up the order of operations. Come on. So, Python. So look, it actually tells you the order. Oh wait, no, that's the description. So what are the order? Wait, come on. Oh, precedence table, yeah. Okay, cool. So assignment has the lowest precedence, and I guessed the value 0 has the highest precedence, whatever that means in this context. So, oh, parentheses, good call, it's not a 0. So parentheses, well, hopefully that's kind of like what we learned even with like math back in grade 6 algebra, right? So if you want, you can have a look at this. If you're like me and you're always nervous about the order of operations, just add your parentheses just to make sure. That's what I do. Does that answer your question? Cool. Other questions? All right. So, okay, yeah, we saw that. Now, be very careful. In Python, let me show you. In Python, if I ask this, it's going to say, well, hold on, that's, oh, right, well, that's also a problem, not. It's going to tell me, well, there's like invalid syntax here. And if I say like, hey, actually, I can't remember if this works in Python. Ah, okay, so. Oh, because it's thinking it's a keyword argument. Interesting. All right. So, in some programming, so Python, you saw when I was trying to do that Boolean check, it was like, you got a problem. And imagine for a second if I had a variable equals 77 or something. But then I wanted to know print or B equals, is A less than 88, okay? And then print B. Great, that's true. But let's change this. Imagine I want to check equality. I realize A is 77, but maybe I'm reading that from input or something. So if I'm checking equality, but I accidentally only do one equal, now it's saying 88? Like, what the heck? This might be a little bit of a problem, right? Because what's happened is Python can like propagate the value. So if I write the expression A equals 88, 88 gets put in A, but it also kind of like gives you back 88. And then I'm saying, well, that expression kind of also got evaluated to like the 88, so it puts that value in A. So here's an easy way to assign A and B. I can assign a whole bunch of values. And now if I print out A, B, C, hopefully they're all 88. Great. I don't really recommend you do this. I strongly recommend against it, but you could. Now, in some programming languages, such as like your C or C++, and these are older languages, especially C. As you can see, this like gives you a value, right? Like that 88 keeps getting like, okay, 88 goes into the C, but then the C passes it on and it passes it on. It's kind of like that expression, which is the assignment. It's kind of like that expression is returning a value in a similar way that like 1 plus 1 returns 2. Like it seems like that. So the problem with some languages, and I'll show you a little bit more about this once we talk about if, but the problem with some languages, like C, is C doesn't have like Booleans. There is no special Boolean. What you use is the value, crap, I always get it backwards. Let me double check. Okay, perfect. Yes, that's right. So, it is what you would hope it is. So 0 is false, and 1 is true. 0, 1. Like it's binary. Boolean. 0, 1, false, true. 1, 0, true, false. Right? But in reality, really, 0 is false. Anything else is true. So if I ask like, if C saw the number 2, in like a Boolean question, it would assume, oh, that's true. So imagine if I'm expecting this to be checking equivalence, but it's like returning a value. Actually, how about this? We're going to put a pin in this discussion and we're going to come back to it in like 10 minutes. Okay? All right. So, yeah, we can keep doing all this crazy stuff. Then we can get back. I've got a video. There I am wearing a hat. So now we can actually ask a question. Because we have a way to check if a statement is true or false. And based on that, we can say, well, if something is the case, do this. Otherwise, don't. Or maybe if something is true, do this. Otherwise, do that. We now have the ability to ask a question. And simply, just with the if statement. So I'm going to copy this. Copy. I'm going to go down here. Paste. So, first, if. If is the all-important question here. Grade equals int input. There. I'm going to hit run. So it's running. I mean, it's waiting for me to enter input. But let's think about what's going to happen. I'm going to enter in a number. All right? For grade. Then, I'm going to ask the question, if grade is less than 50. Now, I want to be very clear. This right here, it's always if Boolean. Now, you might look at that and be like, that's not a Boolean. Grade is going to be an integer, and 50 is an integer. You're right, but that is an expression that gets evaluated to a Boolean ultimately. So first it's going to say if, then it's going to do the number crunching, where in this case it's going to check is grade less than 50. And that's going to be true or false. So that's the Boolean there. This is key to remember. It's always if Boolean. It always got to be a Boolean. I could have a gigantic expression like that silly example I was showing you earlier. As long as it gets evaluated to true or false, the syntax is correct. The syntax is correct, maybe your program is nonsense, like the previous example, which was absolutely nonsense, but it'll evaluate it. So this is good syntax. You will also notice the all-important colon. And on top of that, just like functions, any code we want to execute, if the condition, like if it's true, is indented. So I'm going to show you a couple other things. Let's say print. This is terrifying. Stop coughing. All right, and then you know what? I should unindent that. Okay, so I'm going to stop and rerun it. So, yeah, run. So, if I enter the number 1, 2, 3, and I hit run, despite me not really explaining what to expect here, other than the high level, if I enter 1, 2, 3, and I hit enter, what should you expect to see printed out? This line is out of the if statement. That's because the execution goes like this. Grade is equal to whatever I input. If grade is less than 50, so I'm asking, is 1, 2, 3 less than 50? Who said no? Who was it? It's false. So we don't execute that code. We just don't. So we skip over that chunk of code and carry on afterwards. So enter. This line is out of the if statement. Now let me hit run again. Except this time I'll enter 34. Well, now grade is less than 50, and all that code in the if statement gets run along with the code outside the if statement. Because the whole block there gets run and then carries on after the if statement is done. And it's done when it gets like unindented. There. Any questions about that? Yes?
Is there a reason why you skipped the line before you unindented it?
Just readability. Yeah, I like it like this because then I can look at it and go like, oh, okay, so that's in the if statement. We're sure if it's on the line right under. No, let me run that again. Like, it's still fine and like, obviously it's not indented, so it's not in there. But for me, I just find it a little easier to read. Other questions? That's good though. Okay, so for the sake of time, I'm going to do this activity together. So what I was going to do, but last time kind of ran out of time, is at the beginning of the lecture, I was going to ask, okay, you might remember I asked, using only Python feature statements we've seen so far, can you write a program that will divide a number in half only if that number is a multiple of 2, which is just a fancy way of saying if it's even, right? Without an if statement, you don't really have a way to ask that question. So I was asking you to do something that was futile, like you couldn't. So without being able to ask a question and answer it, to make that decision, it wasn't going to work out well for us. But now we do. So now I can write that function. Where is it going? There we go. So if I go down here, I can say, let's make it a function. Def n. Okay? So what is it supposed to do again? Okay, perfect. So I need to ask if n is even somehow. And then if it is, I'll say like n equals n divided by 2. And then at the end, I'll return n. And the reason this is fine is because if n is even, n gets modified, and then outside we return that new modified n. If n is not even, well, we just skip all this code and just return n, which is what we wanted. If it's even, divide it by 2, otherwise do nothing. Perfect. Now, of course, this won't work because, will it work?
No, you just defined it, so I don't think.
Yeah, but
You wouldn't want it.
where it doesn't know what even is. Interesting. Let's see what happens.
I'm kidding.
Yeah, me too. All right, cool. So it's saying even is not a thing. Yeah, well, that's not how you would check if a number is even. And for programming, typically what you want to do, and this is probably the most common usage of this, is we use a special operator called modulo. It's a percent sign. And what this means is do division, but tell me the remainder. That's what it is. Do the division. I don't care what the result of that is. I only really care about the remainder. And to prove this is right, so this is saying do 66 divided by 4. All right, what was left over? So just to prove, if I do print 66 divided by 4, we get 16. 16 times 4 is, well, that's 32. 64, right? And then what's left over if I have 64, but I want to divide, like I got the value 66, what am I left with? 2. So the mod is a great way to get a remainder. And this is going to be handy because what would happen if I run this now? 64 mod 4. 0. It goes in 16 times with remainder 0, which tells me that this number, if the remainder is ever 0, this tells me that the number is evenly divisible, perfectly divisible by whatever the right-hand side is. So if I ever want to know if a number is even, I can just do like mod 2. If it's divisible by 2, it's even. 1. 2. 66 evenly divides into 2. Yeah.
So the double slash, that's just so it comes out as an integer.
Yeah. Exactly. Yeah. So here, I'll just do this. No, not that. Mod 2. Great. Now if I hit run, when I hit run, I should print this out. Ah, you're right. Huh, that's actually funny because I was actually, all right, I'm going to get back to this. That's equals 0. Now it works. Before I wasn't getting a Boolean. N mod 2 gives me back an integer, and I was saying if integer, which wasn't very helpful. So I need to say, okay, do that division. Now is the remainder 0. So, now, imagine for a second you're using a programming language where, let's say for fun, my function just looks like this. And I hit run, and here I do 55. It shouldn't be that, but if I do 0, I'll divide 0 by 2, and I get back 0. All right, great. It's a stupid function. But n equals 0 gives me back a Boolean. So now let's pretend I go back in time, and this is C, where 1 is true, 2 is true, 3 is true. Every number is true except 0. So imagine I accidentally write this. This is going to say invalid syntax because Python is nice like that. C would go, oh, so you assign the value 0 to n, and that kind of also gives me back 0, which means false. So no matter what this is, it's always going to be false. because we're like propagating that 0, and 0 means false. I mean, if this was 10, all right, great. This would end up always being true. Because I'm not asking the question, is n equal to 10? I'm saying, oh, put 10 in n, and remember, n kind of also like propagates that 10. And 10, it's not 0, so it's true. Long story short, thank goodness it's not C or C++. Because Python goes, I don't think you meant that. Which is true. Yes.
What is C or C++ do instead?
Well, it doesn't look for a Boolean. It looks for an integer that is either 0 or not 1. If it's not 1, it's true. If it's 0, it's false. So that's why, if that 10, it's going to go 10. Well, that means true. So run the if statement. Now, I'll show you another perhaps silly example. If true, when I hit run, what do I have to enter for this code to print out, this is silly? Anything. Not even an integer, it doesn't even matter. Actually, I guess if it's not something that could be turned into an integer, it would crash. But really, I could enter, like, it doesn't matter. If true. True is always true. So if you ever write if true, that means always run this. So yeah, so then why have the if? Just write that. Because if true always runs. Similarly, if false, that code can never run. Never. If false. Well, false is always false, so that means don't run this thing in the if statement. Yeah, so in this case, either this is the bug or this is just done. So, yeah, and you can compound just like we saw before. Here's like a silly example. I go here, I'm just going to paste it. So I've got a long condition, but all that matters is that whole expression gets crunched down to a Boolean. So let's see if we can interpret it. If grade is less than 90 and personality type A and desired career is med school, it's not really a career, but okay. Or if grade is less than 100 and personality type is AAA, apparently, it prints out, time to ask for extra credit. Cool. Now, I don't have all these variables defined, so it wouldn't run. But if all those variables existed, like desired career or personality type and all that matters is that whole expression gets evaluated to true or false. If it's true, if it gets evaluated to true, the code in the if runs. Otherwise, it doesn't. Now, computer scientists are really, remember I was telling you we're so stupid. We can't do anything that's not like step by step. As soon as you make it complicated, it's confusing. And we're really lazy too. So like this is really common. Like if x is greater than 10, do something. If x greater than 10 but not that, do something else. This is so common, where you have like a choice to make. It's not like, okay, if something's true, do this and then carry on. It's okay, no, if something's true, you're either going to do this or that, but only one, and then you carry on. That's effectively what this is, but computer scientists are so lazy. We came up with a shorthand for basically exactly this. If x is greater than 10, do something, else do that. It's the same idea, just a little easier. Any questions about that? Yes?
How do we do if x is greater than 5, do something. If it's greater than 6, do this, and like keep doing that a couple times.
Well, you can do a series of if statements and just keep asking to check if the condition's true. But alternatively, we can do this. Elif. It's, okay, well if this condition's true, here the idea is, I only really want ever to print out one of these statements, one of these strings, right? So I ask the question, okay, if year is less than 1960, print out jazz. Great. If I don't print out jazz, all right, carry on and ask the next question. Else, if year is less than 1980, and let's say year was 1972, right? So 1972 is not less than 1960. Therefore, it's at least greater than, perhaps equal to. But then I go to the next one. Oh, 1972 is less than 1980, so we print out rock. But then, because we've got all these else ifs, the idea here is we only ever actually want to run one of these ever. They're like mutually exclusive. I will only ever run one of these. And I'll show you. Whoop. There, I made year 1908, I hit run, we see jazz. It runs the first one, and because it ran the first one, it just skips the rest of the chunks of the else ifs. If I do 1972, like I said, rock, great. But, and now you might be saying, okay, else if, great. But here's the thing, I could write this another way, but I gotta be careful. If I don't do else ifs, suddenly they don't become like mutually exclusive. So if I put in 1908 again, it prints them all out. Why? Well, look at the code. What does the code say? Is 1908 less than 1960? Better than this next time. Is 1908 also less than 1980? Is 1908 less than 1990? And you see. But when you make it the else ifs, it'll only ever run one. Yeah?
That works too if you do the year is greater than and small.
So this is how I'd have to fix it. I could say, okay, so if year is less than 1960, so what I'll have to do is, okay, if year is greater than or equal to 1960 and year is less than 1980. $1980 and that, and then we'll have year is greater than or equal to 1990 and that. Well, now we're in great shape, except the else kind of messed us up a little bit.
Because the else only runs on the last.
Yeah.
Right?
Because it goes, oh, okay, I checked this condition. It's true. This condition, well, 1908 is not greater than 1960, so this is false. Similarly, this is false. This is false, but this is true. Or, pardon me, this is false, but the else always means, well then, like, otherwise. So that's why the else kind of gets messed up there. Long story short, especially when you're learning this the first time, be mindful of the difference between if, else, elif, which is that else if, and those consequences. Don't worry, there's only like the 3 things you need to think about, and if you forget, which you might early on, just reference the lecture notes. But after a couple of times, once you get used to it, you'll never forget the difference again. It won't take very long at all. So yeah, else if. And yeah, I suppose we'll stop here. Now, by the way, you can nest if statements actually. Like I can say if x is greater than 0 and then go inside and do if y is greater than 0. Like I can nest those things. That's fine. I mean, I could achieve this with an and statement. I could say if x is greater than 0 and y is greater than 0. It would be the same thing. But maybe you want to nest them. Don't ever do this though. Don't nest this much. Python actually won't let you. Python, funnily enough, actually has a limit of 20 deep. Other programming languages have way more, but anyways, I'll say this again next time.